Welcome to the new webinar, Rapidform plus Creaform. This is a cooperation webinar between our both companies. We want to show you how to enable streamlined and highly accurate inspection along with a fast path to CAD. I'm Tobias Klein, Product Manager of EMEA for Rapidform, and my co-demonstrator is Guido Hoos, Technical Support Manager for EMEA, also from Rapidform. First, I want to excuse, because the last webinar we did a recording, but somehow the recording failed. So the people who joined the last webinar and want to review the webinar again are welcome here. That was a German webinar, so willkommen unsere deutschen Folgenden des Webinars. Wir haben im letzten Webinar eine Aufnahme gemacht, die ist leider verloren gegangen. Dafür entschuldigen wir uns, und es wird jetzt im Anschluss an dieses Webinar wird es eine Aufnahme geben. Das Webinar ist leider in Englisch, aber trotzdem willkommen. Ich hoffe, Sie können uns hier folgen. Vielen Dank. Thank you for welcoming our German followers. So, we will proceed like the following. I will show a basic introduction slide, and after that basic introduction slide I will show a live demonstration of our reverse engineering program, Rapidform XOR, and then I will pass to my colleague Guido Hoos, who will show a live demonstration of our inspection suite, Rapidform XOV, and after that we will have some time to answer questions. So now basically the Rapidform company is in three main areas of the world. We have our headquarters, which is Untitled Technology Inc. in Seoul, South Korea, and they cover Asia and Oceania with 102 partners. There's the Rapidform R&D Center, Rapidform HQ, and Rapidform Japan. And we have a second branch in America, which is Rapidform Inc. with 84 partners and Rapidform Inc. headquarters. And we have a third branch in Europe with 68 partners, and this is Rapidform EMEA headquarters. And Rapidform, actually Untitled Technology, was founded in 1998, and we have now approximately 100 employees, and sales and support is available in 37 countries. We have worldwide over 250 sales partners and already sold over 10,000 licenses worldwide. Our partner company Creaform is also a worldwide operating company, which has offices in 6 countries, over 160 distributors in 50 countries, and clients in over 85 countries, and 3 major technical support centers. Their growing is annotated by 3 acquisitions in 3 years. They have 2 OEM partners, over 17 products launched in 10 years, and over 2,500 units in the field. And they have expertise, over 118 CAD employees and 42 metrologists, 3D scanning specialists, and over 10,000 3D engineering projects realized already, and over 20 employees in R&D. Creaform develops and manufactures scanners, scanning hardware actually, portable 3D scanners like the HandyScan 3D, or portable optical CMMs like the HandyProbe, which we will use in the demonstration of ISO Verifier, and optical CMM 3D scanners like the Metrascan, which can be tracked in space, and optical coordinate measuring systems like MaxShot 3D, and the actual tracker, the dynamic tracking module VxTrack, which is used to track the HandyPro Lemaitre scan, and 3D body digitizers. So our main product is Rapidform XOR and Rapidform XOE. This is Rapidform XOR, the fastest path to CAD. We actually use any point cloud data which can be captured using 3D scanner hardware or 3D probing hardware. And we use that 3D scan data to generate parametric CAD models using a CAD-like approach and using several wizards to simplify the modeling strategy. And then we can output the native CAD file using a live transfer process, or we can store several neutral file formats which you can load in any known CAD software. So the main CAD softwares we support is SolidWorks, Unigraphics NX, or now Siemens NX, ProEngineer, CATIA, and Autodesk Inventor. And we support also STEP, IGES, and Parasolid file formats. And for input we support many scanner formats, among those the Creaform scanner hardware direct. In Rapidform XOE we have an easy and accurate inspection suite. So in this program you can load your native CAD files like SolidWorks NX, ProEngineer, CATIA, or Autodesk files, and together with those native CAD files you can also load your product manufacturing information, and then you can use your scanning hardware to make a scan or probe on the scan data, probe on the CAD data, and directly create vivid reports in the XOE and export those reports, inspection reports, to PowerPoint or Excel or PDF or as XML file, ASCII file, whatever. Or you can download the free Rapidform Explorer. It's a free viewer from our website to share your reports with others. So this is basically a short introduction in our setup, and now I'd like to show you some real demonstration of XOR. We want to see the reverse modeling of this part. This is valve casing. This valve casing is scanned already and meshed. So you can see here when I activate the point mode, you can see here are points in space, and the triangles actually triangulated. So we have a shell mesh, and this shell mesh looks already like it can be constructed in CAD. So it has revolutions, it has extrusions, it has features which you can recognize with your human eye. However, Rapidform only sees points and triangles right now, so we have to tell Rapidform how to recognize the features, and therefore we have this region group auto segmentation, and we segment that mesh into several regions which have similar curvature, and we compare those regions and combine regions which belong to the same feature. So this calculation takes a while, and we can see various colors which separate each region from another, and there you can see planes and cylinders and revolutions or freeform, whatever. And they're just colored arbitrarily first, but you can change those colors. If you don't like that color, then you can just pick that color and go to the properties panel and change that color. And we have another view, which is the geometry type display mode. So in the geometry type display mode, the colors are set up by feature type. So if you have a plane, then you get one color, and if you have a cylinder, then you get another color, or if you have a torus, then you get another color. So you can set those colors in the preferences. Here you can see the preference panel, and we can see those colors. So once we did that segmentation, we can work from those planes or cylinders as if it was CAD. So I can just define, I want to draw on that plane, or I want to project that plane onto that plane. So I could just create a plane on that using a offset or big point in coplanar axis, for example. Pick a plane here. Or get the plane here and extract it. And in this case, we can use a best fit algorithm, which can which can filter out noise which is introduced by the scanner. And we can also use an axis constraint, so we can use another plane which should be perpendicular to that one. And in this case, we have a plane here, so I can get this plane for a CAD construction. And now sketching, like in CAD, is we have a sketch mode here, and we have a mesh sketch mode here. The mesh sketch mode has the advantage that I can get a section or a silhouette from the CAD, so I can move my section inside the scan and get a silhouette or a section. And on that silhouette or section, I can do my 2D sketch, which I need for that feature. So, for example, I could just double-click each line and I could fill it, those areas, and manually draw this. And as you can see, I'm heavily relying on that pink line, which is actually my section through the scan. And now we have an accuracy analyzer. This accuracy analyzer can compare my CAD sketch with the actual section through the scan. And I can view my deviation. There is an easier way to do that sketching. We call this auto sketch, and in auto sketch it automatically creates sketch curves which you pick. So you can pick 1, 2, 3, 4, 5. Let's say we pick that sketch chain which is created, and it's automatically creating a vertical constraint, and it's automatically creating coincidences and tangencies, and you can then create a construction line, for example, from the middle, and over this construction line you could mirror this area, and then you could connect the endpoints, and so you get also your symmetric constraint. So in this case, we created just one sketch, and now we can rely on CAD data, on the scan data again. So I'm forming that extrusion from here, going to a region which is inside my CAD, inside my scan. So you can see here I'm snapping to that region, and I can check my deviation within the specified tolerance. Let's say this is cast, so it's plus minus 0.25. So I can check my tolerance during the modeling. So this is one manual way to do it. Another way would be an automatic way. So you can just right click on a feature and I can just say insert and merge, and it's trying to figure out which elements belong to that feature. And it's getting my axis, and it's getting more profiles or something. So I can also get a partial shape. In this case we have 360 degrees, so we don't need, we need the full shape. And now we can guess profiles and extract profiles. Now I can enhance or decrease the resolution, or can go back and add more features like this, which should be also revolved. So this is more or less the automatic version to get that profiles and to create that solid bodies easily. And that is extrusion and revolution, but it also works on sweeps and lofts. So we can have a look at one from here. Say I will create a profile here, and I will extrude that profile using a manual method. I'm just clicking here, combining this line tangent to this circle, deleting what I don't need in this inner area, creating a coincidency, creating a tangency. This is automatic. Then I can use a construction line and mirror this over to the other side. Again, create a tangent line here, create a tangent line here, and delete what I don't need with power trim. Create coincidencies and create tangencies again. This should be horizontal, this should be horizontal again. Coincidencies, tangencies. So now we created that profile quite quickly. So I can extrude that profile, just basically down to, let's say, 15. So, and on the bottom we have another profile. Just moving my plane down to, let's say, minus 55. Get that profile as well as a mesh sketch. So now here we have a circular profile, so I can just click the elements of that circle, double click it, and finish my circle. And now let's just hide the others, hide planes, vector, and now I can create my lofted body from this body to this body, and this is my lofted body. And also here you can see the deviation when I increase this tolerance value to 0.25. Then you can see this is what comes out as an extrusion, as a revolution, and as a loft. So this is basically the parametric approach in XOR. And I already prepared a little bit. So final model, or not yet final model, but very much progress model, should look like this. And we have several other functions, like, for example, like to input a fillet area. To create a fillet area, you can just click the fillet area, click the fillet button, and you can automatically estimate the fillet area from the mesh. So it could on the mount propagation. So we could estimate the fillet from the mesh, and we can directly see the deviation. And what happens if I get bigger or smaller fillet. So I'm creating a fillet about 6 or 7.5, so 6. So this is XOR. And finally, we could export that file to several file formats, as we have IGES or STEP or Parasolid, text or binary, ACES or CATIA v4, v5, or we could live transfer that file to SolidWorks, Siemens NX, to Creaform, AutoCAD Inventor, or save it as CATIA v4 or v5 file. So this is basically the workflow. And yeah, that is XOR, and now I'm giving to my colleague Guido course and will demonstrate the suite.
So, welcome to the short demonstration of XOV3 using a Creaform C-track to verify some important features on our test part. Now, the first thing you want to do when you want to verify a part, after importing the nominal file of course, is to align the part with the measuring device. Now this is a very easy thing to do in Rapidform. So let's click on a line and just do an adaptive alignment. So on the part I now can set several points I can use for alignment. So these points are not only points on the part itself, they are defined as point pairs, and these points are defined by the point on the part and by the measurement. Now, of course, the measurement is not done yet, but it will follow as soon as I give the OK. So, by clicking the OK, Rapidform shows me the point to measure, and the simple thing is I simply have to measure this point. I get a confirmation by a beep, and the next point is highlighted and it has to be measured. As soon as I have 3 points measured, I also have the probe on the screen, so that is easy for me to recognize if I'm in the right space. So if my probe is too far moving, Rapidform or C-track automatically sees that this measurement is not safe and I will have to measure again. That happened. And after the alignment is done, we can easily find if the alignment was correct by placing the probe on the part. And you can see the delta from the aligned part to the measured part, and I can save these values by simply clicking on the part, and now you can see that it is a quite nice alignment. It's within only a few hundredths of a millimeter. So if I'm satisfied with that, I just can click OK, and then Rapidform asked me what I want to do next. So I could continue live inspect. Now this has been done. I can exit, or I can retry and iterate the alignment if my evaluation was not suitable. So for this one I want to exit live inspect, and that can be done by using the probe, the handy probe. So I do not have to walk over to the computer. So for next thing, I simply want to set some dimensions. Now this is also a quite easy thing. I simply have to measure some surfaces, and the surfaces here are really easy to touch.
Planar face.
And it's also very easy to do some live dimensions. Now this is the first plane I measured, and I'm confirming it. Now the second plane I want to measure is this one.
Planar face.
And I'm also measuring it with 4 points.
Angular dimension.
And what you can see here is that Rapidform automatically did an angular dimension from it, because these planes are not parallel. And so there is an angle in between them. It should be 21 degrees, and it has a tolerance set by plus minus 0.1 degree. So this measurement is automatically put into the database, which can be reported later on. So let's add some more dimensions. So the next one could be the distance from this sphere to this sphere. So I'm simply measuring it.
Spherical face.
And also Rapidform here recognizes which face I'm measuring, and it gets the values for it. So, and let's measure the next one.
Spherical face. Radial and linear dimension.
So here 2 dimensions are possible, and we've got a radial dimension for one sphere, and we've got the distance in between those 2 spheres. And as you can see in our parametric inspection feature tree, these dimensions are now added. And I could continue for a while to add some more measurements, and also set the tolerances for these measurements. So in the end I would have a lot of measurements in my feature tree. Now this is pretty nice, but it's a manual way, and I don't want to do it a second and a third time by defining dimensions and so on. So what I'm now going to do is I will open an inspection feature tree and a new program I did before, and then you can see how easy it is to evaluate some more features on this part. So I simply open a new file. Don't save that one. That should be on the desktop. Let's take this one. So here's the part I did before with some more dimensions. And what I'm going to do now is just inspect it. I get that message. So, and in here I can decide to continue live inspect or to reset all probe data. And that's what I'm going to do. I will reset all probe data. And then Rapidform just asked me for measuring these points. And I'm now not touching the computer at all. I'm simply probing on the part. So here's one point. Here's the next one. Just as defined before. And Rapidform very nicely shows me again where to touch the part. So that's what I'm doing. And the automatic workflow by using the inspection feature tree, of course, is very similar to the one we did before. Also here our deltas are nice according to our alignments, as it should be. And if I confirm, I'm asked to do the next inspection features or recycle or refine the alignment. Now I want to go to the next features, and now Rapidform highlights every surface I have to measure for the evaluations I'm going to do on the part. Now the order how to measure these faces is free, so you can decide which one to measure first. So let's start with this
Spherical face.
And you can see that Rapidform gives you a feedback which face you're measuring. So let's take some points. Number 1, second sphere.
Spherical face.
As soon as I confirm, I'm guided to some next phases. So let's take this one.
Planar face.
And Rapidform shows you, if you don't have so much features left, where new or features are which are to be measured. So there's a green arrow, and you can continue measuring the faces where the arrow points on.
Planar face.
Of course, you don't have to completely follow, so I also
Planar face.
measure this face first. And then take that one.
Planar face.
So 2 faces left.
Planar face.
One face left.
Planar face. All geometries measured.
So by this one, you just can exit the live inspect and the part is evaluated. So this is also very useful for a worker self-control. So there has to be, of course, a person who will write the inspection feature brief, but then the, let's say, program or the file can be opened by a worker and very easily controlled by just probing the highlighted faces. Of course, we can do more. We can also measure geometries. Now, by measuring geometries, we have an automatic tool which automatically recognizes the geometry you're measuring. So this does not have to be on a CAD. That happens automatically. You could also measure a part without CAD. So by clicking first 3 points, Rapidform will recognize a plane. Of course, because a plane is defined by 3 points. But if there's 1 point more, Rapidform automatically recognizes that it is a sphere. And by taking some more points, you also get some roundness. Now let's confirm it. And the sphere is measured. Or let's make a plane like this one.
Plane.
And as you can see, a plane is recognized. So this will be enough for probing. And I'm leaving the geometry. And I now could also do some other things like measuring dimensions and so on. So the last thing I want to show now is how to do a report from that. Simply click on Report, and in there you have all the things you did before. Now, of course, some things might not be inside the report, and we could also easily hide these by pressing the check marks, and then this one will not be in the report. Additionally, we have a very nice field for the person who is probing and measuring. So you could enter some keywords and the inspector, the department and so on, and then simply create a new report. Now this report will be done automatically, and it can be in various formats, also showing a cover with your company logo and some other state-of-the-art features, and it can be defined to the things you need. Now after a while the computer is generating the report, you can see the cover page, which shows a company logo and the main information, so the inspector, department, name of the part, product name and the date, of course. And the next page, it shows the nominal data. We have the information about our alignment. We have the alignments or the measurements we did, and that happened automatically, showing the actual value, the deviation and the tolerance, and a color-coded field. So these colors are just like traffic lights, and in there it means green is inside tolerance, yellow is still inside tolerance but outside a warning tolerance, and red simply means outside the tolerance. So that is also very easy to see if the part is okay or not. So then we have all the points probed until now, and also the comparison points are shown in a nice layout, also showing the color bar and some more information on them. As you can see in the foot, there's also again the information you entered before. So on every page you can see who the inspector was and which part it is and so on. So then several things have been measured later on. So there's a plane. According to the alignment, there's a sphere with the information and so on. So this is, in I think quite short words showing the great functionality of Rapidform XOV3 when it comes to probing. So thank you for your attention for my short excursus, and now I would like to pass back to Tobias so we can continue with some questions. So Toby, if you could take back the screen.
So, thank you for your attention, and now we have a session for questions. I already received one question. Are all of these probings taken manually, or if I have a CNC run CMM, can they be taken automatically with that? Actually, we can virtually read any point cloud data format and inspect it against CAD, but the demonstrated method is designed for articulated arms or for tracked probes. So we cannot control a CNC or bridge portal CMM drive yet. This is not possible, but if the CMM can export ASCII files of points or reference geometries or even bodies, CAD bodies, measured CAD bodies actually, then we can compare, we can import that, and we can compare that to the CAD file. This question answered. Okay, great. So, any more questions? I get one question here. That big menu on the screen of XOV, is that operated by mouse, or how do you operate that big menu? Guido, could you explain that?
Could you please repeat? Could you please repeat? Toby?
The big menu in the, the big menu in the middle of the screen in XOV.
Okay, yes.
Is that operated by mouse?
It can be operated by mouse or by using the probe. So if you're moving the probe, it also works as a mouse for these menus. So moving up the probe will move up the mouse pointer on the menu.
Okay. And another question, is it possible to calibrate a probe in XOV?
Yes, that's also possible. So by connecting to the device, you will have the full functionality on an extra menu, which can be hidden afterwards. So you can only see XOV. But you can access the functionality of the firmware, and in there, of course, you can also calibrate the measurement device.
Okay, does that answer your question? Great. Okay, any more questions? Okay, here's one. Are the devices mentioned at the beginning of the demo independent inspection devices, or do I need an articulating arm like a Faro or a Roamer to use this software if I don't use my bridge CMM, that is? So basically the devices mentioned at the beginning of the demo from Creaform, they are independent. So not everything is independent. Actually the probe needs a tracker. And also the Metros scan, which is actually a scanner, he has a surrounding case with markers on it, and those markers can be tracked as well. So they need a tracker to get their position in space. But the point acquiring or the scanning itself is done by them solely, so you don't need an arm. For the Creaform handy scan, actually, this is using a dynamic reference, so you can even move the target and the scanner. And it is referencing itself using markers stick to the target or markers stick to the base of the target. So you don't need an arm for this. You're welcome. Okay, some more questions. There is one question. If this is not secret, where is your public new version? Okay, we are in the final QA stage of the new version, and it is about to be released, so it can be only weeks left. The release of XOV3. So another question, can we use this software to obtain surface roughness of the object scanned? Actually, if your scanner is capable in capturing the surface roughness in the desired accuracy, then you could use, for example, the color deviation mapping and the tolerance to see where your roughness is out of tolerance or in tolerance. This is possible, yes. However, your scanner or point acquiring device has to have a accuracy which is inside your roughness. Okay, fine. Next question. Okay, I have a question here. Using the handy probe, what kind of alignments are supported? Guido, if you may answer this.
Okay, so if you're using a handy probe, as you have seen in the webinar, you could do an adaptive alignment, which is done with several defined points. But you also could use alignments like 3-to-1 if you do not have any CAD, but still want to have an evaluation of your part, which is relying on axis of the part. We have an alignment using, or let's say, in other words, we also can then connect the metra scan, which is also tracked by the C-track, and this metra scan will still be in the alignment which you did with the handy probe. So this is also very useful because you can then combine probed and scanned data for verifying your part.
Okay, does that answer the question? Great. So there's more questions about the cost of the new software and about whether we can install the software in more than one computer. Actually, we have several licensing methods. There is a licensing method which is called a floating license or local network sharing license. So you can install the software itself in arbitrary number of computers, and you have a certain number of licenses pooled on your own server in your company, and the user which needs a license just connects to the server and gets his license logged out, and the next user get the next license which is available, and if no more licenses are available, then one user has to wait until another user returns his license. So the licenses are pooled inside your company, but the software can be installed on any computer with hardware requirements, of course. And what does the software cost? The software as a full package is about 20,000 euro, but there are always some opportunities, so I think you should talk to your local vendor, or you should have a talk with our EMEA office directly to clear that question, because that is just a number, it's just a list price, and there are always other opportunities. Okay, so there is another question about costs. If you have Rapidform XOS and you like to upgrade to Rapidform XOV, then that is a cross-product upgrade, so it will not be as expensive as a new purchase, but of course it will not be as cheap as an upgrade inside the product lineup. So if you have Rapidform XOV2 to upgrade to XOV3, does cost less than from XOS to XOV. But as I said before, you should talk about that pricing stuff with your local dealer or with our EMEA office directly. So there are several opportunities, especially after the launch, and I think they can tell you better than I can. Okay, what is the main difference between XOR and XOV for applications such as scanning of rock aggregates? Oh, that is a special field of rock aggregates, okay. The main difference between XOR and XOV actually is XOR is the reverse engineering package, and XOV is basically an industrial inspection package. So if you have a part already there as a CAD file, or if you have a manufactured part and you like to prove that the quality is okay, then you should use XOV to make the quality check. And if you have a part but you don't have a CAD file and you cannot manufacture that part because it has no manufacturing data, then you can use XOR and capture the part, the physical part, and bring it back into a data format which you can modify and from which you can manufacture. This is XOR. In case of reverse engineering, we have two different products. We have XOR and we have XOS. XOS is a smaller, more lightweight product than XOR. It is much less cost intensive, and it is tailored especially for parts which are not prismatic, which are not industrial, which are more organic or ergonomic or artistic maybe. So XOS would be the right solution for very much freeform shaped parts which are not manufacturable, and XOR is the industrial solution. Regarding the order of cost of HandyProbe and XOV software system together, you might want to contact Creaform directly. We will give you the information about the Creaform contact persons after we collect the attendee list from that webinar. So that webinar is recorded, and also the attendee list is recorded and is passed to Creaform. So if you like to get a quotation, then you can get it directly from Creaform. Okay, more questions? We have still some minutes. Last chance. It's not the last chance. Actually, if we have more questions, then we can also reply to you by email. So as I said, the questions will be logged and the attendee list will be logged. You will get a thank you email. You will get a link to the recording. Again, I want to excuse that the recording the last time was not successful. Somehow the video file vanished, and we want to apologize for that. So this time we will record it 3 times. That one recording will succeed, and you will definitely get a recording of that session. So. Okay, so if we don't have any more questions, then I want to thank you for your attendance and for your interest in Rapidform, in Creaform, and yeah, I hope we could answer your questions well. If you have more questions, then you can use the email address. You can write to eusupport@rapidform.com. I will post that in the questions panel, so you can get the questions to eusupport@rapidform.com. Okay, Ben, thank you for your attendance, thank you for your interest, and I wish you a pleasant day.